Here we have an example of something that might be more of a commercial application of photovoltaic systems. We have several photovoltaic panels. We have two sets. We have one type on this structure. We have another type on the structure behind it. Both are mounted on what's called one-axis trackers, in that there are electric motors which turn these panels such that they track the sun as it goes from the east to the west. With this type of tracker, it's fairly sophisticated in that it's computer-controlled tracker. There is a little computer in here that runs some very sort of mid-complexity algorithms that knows the latitude of your location, where you are, Las Cruces, New Mexico, 32 degrees latitude, and it knows the day of the year, for example, January 28th, day 28, and it knows the time of the day, 2 o'clock. With that information, it can predict exactly the angle of the sun relative to east and west, and it knows to turn the tracker exactly that many degrees every day to point directly to the sun. This increases the efficiency, or the amount of electricity that comes from the solar panels, but you have some additional complexity in your system. These are what's called active trackers, in that it requires electrical motors, it requires some mechanical components, some electrical components, and it tracks the sun, but you get more electricity from this type of system. This system is a German design, and it's being tested here at SWTDI. Right next to it, we have a good bit of data collection that is brand new, very sophisticated, and it's connected via cell phone and landlines, such that all the data, which is being collected real time, can be accessed through a cell phone from anywhere in the world. For example, at the headquarters of the German company who's looking at the system design and the system components and seeing how they're interacting. You can see on this structure here that we have a couple of instruments that are being used to characterize the sun's energy. These are called pyrometers. They're reading the amount of sunlight, so we know how much energy is striking the surface, and from that we can see how much energy the panels are delivering to us and determine the efficiency of the panels. So a lot of instrumentation is going in this because this is an evaluation system. But this might be a system that might go into, for example, a desert environment over several acres that might be a large-scale electrical production. Tracking the sun in some cases is very important, especially on systems that use a new type of system with lenses called Fresnel lenses that are used to concentrate the sun onto a smaller section of photovoltaic. So the total amount of photovoltaics that you need is smaller, but they produce the same amount of energy because you're concentrating the sunlight onto the cell. So we're looking at two different types of modules on the same structures under the same ambient conditions, the same location, the same amount of sunlight, and we're comparing those, seeing how efficient they are relative to one another and relative to traditional solar photovoltaic systems.
The preceding was a production of New Mexico State University. The views and opinions in this program are those of the author and do not necessarily represent the views and opinions of the NMSU Board of Regents.